Okay, so welcome everyone to our webinar. Topic is artificial intelligence driven in predictive analysis. So I'm as your moderator today. Um, so to give introduction, today we have three speakers. So every speaker that join us today will be given 30 minutes uh, on each of them to present their topic. I just want to remind that for those who are joining us today, please register at our form. So I think we will show you the QR code later. So do we have QR code at this moment? So you need to scan the QR code and then register. It's very important for us to issue you a certificate, and you need to fill out the form lah. Okay. So any question you can post at the comment section at the Facebook and the YouTube. So we will post or ask a panel or the presenter about the question that you ask. So a warm welcome to today's session on the exciting frontier of artificial intelligence driven predictive analysis that we have. Hold on, yeah. I need to. Okay. So warm welcome to today's session on the exciting frontier of artificial intelligence driven predictive analysis. It's a pleasure to have you all here as we delve into how the cutting edge technology is reshaping industry and transforming the way we make decisions. Okay, so we see that AI is very, very important today. And what makes today's discussion even more special is that it will be presented by our PhD student and lecturer who bring us unique blend of academic rigor and real world insight to the table. As someone deeply immersed in the world of research and education, our presenter embodies the spirit of innovation and inquiry that drive progress in the field. So we can see that AI has rapidly emerged as a game changer in predictive analysis, enabling us to unlock insight from vast dataset and anticipate future trend with unprecedented accuracy. Okay, so without further ado, I want to invite and welcoming our presenter, a PhD student and a lecturer who expertise and passion promise to make today's session both enlightening and inspiring. So we have three speakers today. The first speaker is Cikgu Muhammad Hanafi bin Teman, and our second speaker, Febi Api Wenando from Indonesia, and our third speaker is TS Dr. Hadrami bin Abdul Ghani, Fsdk Deputy Dean. So each speaker will have 30 minutes on their presentation. Any question can be posted on the comment section, and then by the end of the presentation, we will ask the presenter. So let me introduce the first presenter, his background. So Muhammad Hanafi bin Teman is a dedicated primary school teacher. So that's why I call it Cikgu Nafi. We can call it Cikgu Nafi. Specializing in technology and design. Okay. His commitment to the education is complemented by his strong background in both material science and information technology, making him a unique contributor to educational technology. So his educational background is his own Bachelor of Science in Material Science from Universiti Kebangsaan Malaysia, UKM, Master of Information Technology from Universiti Malaya, UM, focusing on practical and theoretical aspect of IT. He also proficient in web development technologies such as PHP, Laravel, and Ruby on Rails. His experience, apart from being teacher, He's a part-time programmer at localhost in Berhad, where he has contributed to the development of security and payment platforms such as DNSSEC, DNSO, and SecurPay. He also earned gold medal at Perisa 2020, recognized for developing the complaint management system and innovative solution that improve organization reason to feedback and issue. So I think that that is explained about Cikgu Hanafi, and without further ado, I think that I hand over the session to Cikgu Hanafi lah, speaker number one. So Cikgu Hanafi, can we start?
Okay.
Okay, so I hand over to Cikgu Hanafi, and yeah, the stage is yours.
Uh, Big thank you to our charming moderator today, Dr. Amir Haris bin Ahmad. We have a webinar today, and the webinar topic for today is artificial intelligence driven in analysis, and we'll be focusing on what is actually the meaning of predictive analysis. Okay. First of all, today I will uh, explain more detail. Actually, what is predictive analysis? Okay. Actually, the predictive analysis is the the most important thing when we want to predict something is we must have historical data. Okay. For example, if simple example, if you want to travel to go to holiday traveling, and the first we must check is flight schedule and same as uh, our vehicle condition, whether is okay or not. And the most important thing also, with the data, is it raining season or the bad storm season. So we will make analyze from we will from the we have if we have the historical data, and we can analyze we from the historical data that we have, so we can make a decision whether this is the suitable day for us to go to vacation. Actually, that's for the example. Actually, for the scientific term, predictive analysis is the use of data or statistical algorithm and machine learning techniques to identify the likelihood of future events and
So is it okay? So waiting
Hello?
for okay, disconnected kan? So
Disconnected.
ah
Disconnected.
you can
Line
uh,
disconnected.
okay, you can continue lah. You can have it.
Can continue.
Yes, yes.
Okay. Um, okay, let I say today for the historical data, we have the traffic patterns, accident of delay, and weather data. Okay, from the historical data, we will can predict what will happen. That's the meaning of the predictive analysis. Okay, and why predictive analysis is important? Okay, actually, predictive analysis is a vital tool in today's data-driven landscape. Okay, and uh, it will anticipating the future outcomes uh, with the higher or certainty of analyzing the real-time data and identifying patterns and applying advanced algorithm productive analytics and enables accurate prediction and forecast. Okay, and also the important of the predictive analysis is we can make strategic decision making. Okay, if like I said, if we have the historical data, so we will make a good decision. Okay, and the third one is the customer uh, behavior, understanding, and personalization. Okay, the analytics will have the organization will gain a deeper understanding of customer behavior, their preference, and their overall needs by analyzing vast amounts of customer data organization. Okay, and can identify uh, buying patterns and offer personalized experience product and customer satisfaction. Okay, next one. Okay, how does predictive analysis work? Okay, the first step is defining the problem. Okay, defining problem is clearly defining the problem at hand to help determine the appropriate predictive analytic approach. And the second one is data. The data is okay. The data is the lifeblood of predictive analysis. Okay, that's mean the organization may have the vast amounts of historical data or continually streaming the data from the various sources like customer interactions. So the first step is to identify and acquire the relevant data, then organize it in a central repository such as data warehouse or a big data query. Okay, the third one is pre-processed data. Okay, pre-processed data is an ideal state for analysis. Right, right. So before developing predictive models. Okay, the third one, is uh, the data needs to be processed properly, and it's involved cleaning the data to remove any kind of uh, anomalies, handling missing data points. Okay. For the predictive model, the models are trained on the prepared data and identify the correlations and the patterns that can be used for making decision. And the last one is uh, validate and deploy the result. Okay. Okay. Why use data models to predictive analysis? Okay. The first one is understanding the data relationship, and the second one is data about the data preparation and transforming, and the third one is features selection, and uh, the fourth is algorithm involved in algorithm selection, and next interpretability and transparency, and the finally iterative development and improvement. Okay, what is the type of predictive analysis model? Okay, the predictive analysis model uh, have five types. The first one is a classification model. The second, regression model. The third, uh, clustering model. Fourth, time series model, and the finally neural network model. Okay. Uh, Actually, the real life of use of the predictive analysis is actually the predictive analysis use from various sectors such as financial analysis, which involving in predicting the financial sector or predicting stock market. Also, sales and marketing analysis, and also manufacturing and supply chain management. And predictive analysis also uh, famously used in healthcare analysis. So the uh, they use the predictive analysis to predict uh, about the patient condition and what will happen to the patient if uh, the uh, they are what will happen to the patient if not they're not doing uh, urgent. They're not doing urgent treatment. Okay, and the also predictive analysis also used in retails and e-commerce of course, for example, uh, if the organization always use uh, the predictive analysis to analyze what is the pattern of their customer behavior. For example, which product that always used by the customer, and which product that the most interested by the customer. Okay, the last one, predictive analysis also can be used in the education sector. Okay, actually, predictive analysis in the education sector consists of academic analytics uh, involving machine learning, uh, classification tasks, and regression. Okay, for the education analytics, the tool is machine learning, classification, and regression. And the last is learning analytic. Okay, LSTM, deep learning, deep ANN, deep learning, and regression. Uh, Actually, uh, for the predictive analysis, I have done bit literature review. Okay, that is the summary of predictive analysis in education. Okay, and for the predictive modeling, the proposed method is RNN and LSTM. Also, uh, from the LR, we can summarize uh, the common predictive analysis that used in education, such as predictive modeling, dropout prediction. Okay, predictive analysis also can be used to detect the dropout prediction, and also student achievement like grade prediction also can analyze student academic performance. Okay, and also can analyze the also can make the grade prediction, and also can predict the up of the student. Okay, that is the summarized table that I have done in predictive analysis by focusing in education. Okay. I think that's all from me, and I give to our moderator. Thank you. Is it? Lighting.
Oh, sorry. Okay. Okay. Again, sorry, I just mute. Okay, let me summary. So the predictive analysis use that Cikgu Nafi already present previously is predictive analysis use data and statistic algorithm to make prediction about future events or behavior. So you have organization to anticipate trends, risk, and opportunity, enabling proactive decision making by leveraging historical data and machine learning techniques. So predictive analysis enhance efficiency, accuracy, and outcome across industry. So there are some questions for Cikgu Nafi. So I read the first question from the Facebook. This one from Nur Sheila Cik Nawi. So Cikgu Nafi, ready?
Okay,
Question.
okay, okay.
Okay. How can we use prediction to help students do better in school without unfair treating some student or invading their privacy?
Repeat,
How
repeat.
can prediction to help students do better in school without unfair treating some student or invading their privacy? So how
Uh,
untuk menolong pelajar lagi excel, lagi do better in school tanpa
can
unfair
school.
kita treat unfair punya ni lah. Faham Cik Alwi soalan ni?
Okay. Actually, like I said just now, the predictive analysis is involving the historical data. Of course, we can help the student to do the better in the school because if we use the predictive analysis, uh, uh, like I said, the predictive analysis, the important thing of predictive analysis, we must have the historical data. Like say their past examination, the past their past result, and we can take the data and make a prediction what will happen in the future for that student. So if we know about the future and we know what will happen, of course we can do something to solve the problem and help the student. That's my answer.
Okay, so that is a good answer for the question. So we have a second question. Uh, as a teacher, do you think predictive analysis helps you in education sector? How can we implement it for the benefit of a wider population like the government or JPN? I
Okay.
repeat the question. As a teacher, do you think predictive analysis help you in education sector? And how can we implement it for the benefit of wider population like the government or JPN?
Okay. Uh, Actually, in this educational sector, like I say, historical data and the predictive analysis. If we want to make the predictive analysis, it's involving the big data. Okay, so of course, I think the predictive analysis, of course, from my opinion, of course, predictive analysis will be the will act as a major role in our educational sector uh, and we can make a prediction what will happen for the future. And if I think the predictive analysis will benefit for the wider population because the predictive analysis involving big data. Okay, that's all from me. That's my answer. I hope
Okay.
it's answer the question.
Okay. We have some other question. This moment we have four more questions. So I try to anticipate all the question. Uh, so next question: what is the software used to run for predictive analysis?
Huh?
What is the software that you use during inside your research?
Okay, actually the famous software that used in predictive analysis is Python. That's answer my the question.
Okay.
Python, Python.
Cikgu Nafi using Python interpreter language. So the next question: what is the most suitable algorithm which can be used in predictive analysis in education? From Ika.
Okay. Actually, the most reliable, famously, and used in algorithm that used in education is LSTM, long short term memory, LSTM algorithm, which widely used in our educational sector. Because if we use the LSTM, uh, it is suitable for the data series. LSTM algorithm is uh, suitable for the most suitable for the data series. Okay, that's my answer.
Okay. So the next question from Nick Marwani: can you describe a real life use case of predictive analysis in education?
Okay. Uh, Actually, the predictive analysis in real life predictive analysis, what a real life use case predictive analysis in education. Okay, actually, the real life predictive analysis uh, uh, actually the question is real life use case. Like I say, the real life use case of predictive analysis is in the evolving in the health sector. Like I said before, lah. Okay, that's my answer.
Okay. So I think this is the last question from Jafri Nasir. How extensive is the application of predictive analysis in Malaysia education sector? How extensive is the application of predictive analysis in Malaysia education sector right now?
Uh, because right now the predictive analysis uh, always used uh, in the Malaysian education sector. And uh, of course the predictive analysis is the most suitable analysis that can be used in education sector. Okay. That's my answer.
Okay, I think that's all the question that we have for Cikgu Nafi. Uh, so we will continue to our next presenter, our second presenter. So before that, for those who are just came in or before, what we already shared a QR code previously. So I think we share again the QR code. Okay, so you need to register for this webinar because all the certificate will be based on the registration form that you submit to us. Okay, so let's jump into our second presenter. So this is very special because our presenter from this presenter from Indonesia. Uh, so Feby Apri Wenando is a lecturer in the Department of Information System, Faculty of Information Technology at Andalas University. So currently conducting research on hate speech detection in the Indonesian language using a hybrid approach. Okay, with a title hybrid long short-term memory and gated recurrent unit for hate speech detection in Indonesian language. So he also a PhD candidate for EMK. So we are pleased to have him today for his presentation. So I think without delay, I hand over the presentation to Fabi. Okay, Fabi, the stage is yours. Thank you.
Okay, thank you, Datu Amir, for the time. Okay, let me introduce myself. My name is Febia Priyanando. I'm currently a postgraduate student in data science at UMK, University Malaysia Kelantan. And today I will to present my research. Yeah, my research in artificial intelligence. I'm a graduate from master at University Gajah Mada in Yogyakarta, Indonesia. I my bachelor degree in Padang State University. And today I will continue what Mr. Cikgu Hanafi told before. Yeah. I will explain one of example of the application case of artificial intelligence prediction and analyze. This my research topic is related to this prediction and analyze. My research topic, which is head speech detection in Indonesian language using hybrid approach. With the title, I used the two of algorithms. Yeah, Mr. Hanafi, as mentioned before, the powerful algorithm, sustainable algorithm is LSTM. And in my research, I use hybrid LSTM, long short-term memory, with the GRU, get recurrent unit, for improvement head speed detection in especially in Indonesian language. Head speech is act of communication carried out by the individual or group in the form of provocation or insult to the individual or group about the issue what happening. Maybe like in Indonesia we uh, uh, we make some president election. So from that election, we have so people with pro and cons the prudential of Indonesia. So the people or individual comes with the prudential, they will make some insult for the prudential uh, election. So from that we can use that like comment in people use social media for express that comment. So we can get data text from the social media. And my research, I use the Twitter, yeah, because Indonesia have bigger uh, user with the Twitter social media more than Facebook. So from the Twitter we get the data text, yeah, from the pros and cons about the issue happens, maybe about ethnic, gender, disability, sexual orientation, citizenship, religion, yeah, because in Indonesia we have five religion, and many more issue can be uh, people express the about that issue. Nah, when we use the algorithm, when we use one algorithm, we call that single method or single classifier. Nah, uh, if we use more than one algorithm, we can call that hybrid method. Nah, single method have pros and cons. Single method have pros. That is one, robust flexibility and scalability, and cons is low about accuracy, fragmentation issue, poor performance on class, uh, especially on when that happen on imbalance of data. Imbalance of data is when the positive class with the negative class is not balanced. We call that imbalance data. When we talk about the uh, machine learning, imbalance data is more important issue to make our system poor of performance. Now, in single methods, imbalance data is one big problem. Now, different with hybrid method, approachnya is robustness, yeah, flexibility, same with the single classifier, scalability, adaptability to data size, yeah. And cons is, I think no cons, but when we use the more than one algorithm, we have to uh, cons. We can make our system, our prediction, more higher in accuracy, precision, kappa, F1 result, F1 score, F1 measure, and many more. And especially increase time complexity. When we talk about the machine learning, if our data more bigger, about the 100,000 billion and more than that, our performa will make time so long of time. So when we use hybrid, yeah, this is will make time more reduced. So this is pros and of hybrid method. Nah, in head speed detection, especially in Indonesian language, the main problem happen right now is one is how to produce quality of data set, because when we get data set we cannot make that, oh, I want positive that only 100 or 1000, negative class only 100 or 1000. No, we don't know when we collecting data, getting data from the social media, especially I use the Twitter. We don't know how much we get the data. So imbalance class is the bigger problem when we collecting data from the social media. And second is how develop feature extraction to improve the as I mentioned Dr. Mr. Hanafi before, uh, in prediction we have the pre-processing. Yeah. Visual extraction is the part of pre-processing, processing of data. Nah, the second problem, how we develop the best, the match, or the best feature extraction for the data we use. Yeah. In my research, I use the fast text and I'm combined with Indo BERT. Yeah. BERT is feature extraction I use in my research. And third, how to formulate hybrid LSTM and GRU for improvement in head speech detection in Indonesian language. We hybrid method or algorithm, LSTM, long short-term memory, and GRU, graphical recurrent unit. And the last one is how to evaluate the result of system our develop. There's performance can be better or not. No, we don't know. The research still. The goal of research is to design and develop hybrid method of LSTM then GRU algorithm for optimizing the detection head speech in English language. My objective study is how to produce the quality of dataset, as I mentioned before, how to make a class in dataset more balanced. In case of imbalanced data, we can use the two of technique to balance data. The one is we can use undersampling technique, and the last one we can use the oversampling technique. Oversampling technique, yeah, that is undersampling technique is we make the majority. Yeah, we just example, in positive class we have 100 data, and in negative class we just have the 50 data. When we use the undersampling technique, we just cut the majority class of positive. We can make the data balance, as the positive class 50 and negative plus 60, so the data will balance. But this technique is not optimized, because we carry out the much of data. The data is more important in the prediction in this case, because we getting data is more difficult. Kemudian the next one is oversampling technique. Oversampling technique is what my technique I use in my research. That is how we make the minority class, yeah, to same with the majority class. Example of oversampling technique like the Adasin technique, like the smoothie, yeah, then many more. And second is my object study is develop feature extraction using Fsdk and Intubert. Maybe this is more important in pre-processing data. The third is how we can formulate the best hybridization of LSTM and GRU to make the optimal result. And the last one is, yeah, we use the how we evaluate our system performance to get the good result. This is LSTM. LSTM is one algorithm of neural network. LSTM is modification of RNN, recurrent neural network, by adding memory cell to that store information to for the long term. As Mr. Hanafi mentioned before, LSTM is good for the time series data. LSTM is to solve the to solve the vanishing gradient problem of the RNN. And GRU is variation of on the LSTM. That is a simple of LSTM, and in some case produce the equally excellent result as LSTM. GRU aim to solve the vanishing gradient problem, which is come with the standard recurrent neural network. GRU combine that forget get in LSTM and input get into the one update get and has the additional reset get, yeah, reset get. Can I my pointer? No. Like the show in this figure. The GRU is increasingly popular and many used to solve the especially an NLP problem. NLP is natural language processing problems. My research study in scope one is NLP, natural language processing, deep learning, feature extraction. We have some multi-class, multi-class, yeah, multi-label on the class. And I use dataset from the ICL Association for Communication Linguistic, especially in Indonesian language. This is the methodology I use in my research. Yeah. Dataset we get, after that we do the pre-processing. We solve the imbalance class with in my research I use the Adasin, yeah, Adasin technique for the oversampling technique. And next I use the introvert, yeah, for feature extraction. After that we hybrid we use the hybrid classifier for the learning algorithm. After that we get the evaluation performance with we can use the confusion metric. This is my purpose work in hybrid classifier. Yeah, I use the soft computing LSTM and GRU. LSTM I use for the short term, yeah, and GRU I use for medium term. I think that one about one of example of case in artificial intelligence of prediction and analyze. Maybe we can get some discussion for the audience. Oke, Datu, saya kembalikan ke Datu. Terima kasih. Wassalam. orang
Okay.
tua itu.
Okay, thank you, Fabi. It's an interesting topic. So if I can recall that currently Fabi is doing his research in uh, hate speech. So and LSTM is using LSTM on a hybrid LSTM. Is it? Okay. So is very important on this topic because we can see that in social media or any because we are interconnected nowadays. So so many in Malaysia also we have so many posting about because we have a whatever keyboard warrior lah. Any issue they post on the social media and then they give their thoughts on the issue, but sometimes it's it just posts based on hate speech and it's not very good lah. Okay, so um, so we have a question from Sheila. I think I will ask this question to Dr. Hadrami lah on your question. Okay, Jafri Nasir, in terms of coding, is it straightforward to embed gated recurrent unit to the LSTM model? Okay, in terms of coding, is it straightforward to embed gated recurrent unit to the LSTM model? Question from Jafri Nasir. So, Femi?
Okay, thank you, Datuk, for the question, Mr. Jafri Nasir. Yeah, that is the good question. How to the straightforward LSTM and Guru. I think it is yes, because it's relative straightforward to the embed the GRU into the LSTM. Yeah, LSTM model, especially in framework like I use the TensorFlow or PyTorch. Yeah, I think, but I not use. Both of GRU and LSTM are types in same model in RNN, yeah, recurrent neural network, and their structure are similar. And for example, we can easily replace the LSTM layer with the GRU layer by changing the type in like model definition. Yeah. However, yeah, it's the essential to note that the choice between LSTM depend on the specific task, I think. But in the case text mining, yeah, I use in my research is good for straightforward LSTM and include because the same in RNN algorithm. Maybe that that's all.
Okay, I hope that answer Jeffrey question. So our second question, using LSTM, what kind of result should be expected, or what should we present and interpret? Is the accuracy only, or what else?
Yeah.
Okay, from
Thank you.
Ika.
Thank you for the. There is a good question. Thank you, Mr. Ika Abdullah. Using LSTM, what kind of results should be expected, or what should we present in interpret? It's the accuracy only, or what else? I think so. Many more we can get from this LSTM, because LSTM model is more powerful algorithm in scope neural network. Yeah, like Mr. Hanafi mentioned before. Yeah, we can get the more best accuracy, precision, and recall F1 score. So I think when we use the ROC, yeah, this will be good. Yeah, ROC like AUC, loss function maybe, so many more. I think that LSTM algorithm is more powerful for the many tasks. I think that good.
Okay. So this is third question. How has predictive analysis evolved with the advancement in machine learning technologies? From Fairuz. Okay.
Okay, thank you for the question, Virus Ayudi. How was the prediction analysis involved with the fintech and machine learning technology? I think that so many has involved in significantly right now. I think like when we talk the big data, big data is more the, I think this technology is more good and important for the automation system. Like my research is improvement model, interoperability, real time analyze, like Mr. Nafi mentioned before. When we use the time series data is more good. Maybe I think that answer.
Okay. So the next question from Hakimi Zuhairi. Why is predictive analysis important in strategic decision making?
Okay, good question. Why the predictive analysis is important in strategic discussion management, discussion making? My answer is because the more important uh, in strategic decision making is like we can anticipate the future trend with uh, the apa trend has been happened before. We can collect data, we can use machine learning for predict the what will happen in future gitu. So we can like first one, we can anticipating future trend. That one, maybe we can risk management, optimizing research, enhance marketing strategy, and I think so many more. Because right now, when we talk the AI, artificial intelligence, is more help us to make our work, to make some decision, uh, so more helping us. I think that question is more uh, helping us. I think that's my answer
Okay.
to Amir.
So I think that's all the questions that we have for Fabi. So once again, thank you very much for sharing your work around or research with us.
Okay.
So thank you very much. So we jump to our next speaker, our third speaker for today. Um, okay, our third speaker is TS Dr. Hadrami Abdul Ghani. He is a distinguished senior lecturer at UC Malaysia Kelantan, UMK, with over 2 decades of experience in academia. He holds he holds a PhD in Intelligence System and Network from Imperial College London, a Master in Telecommunication Engineering from the University of Melbourne, and a Bachelor in Electronic Engineering from Multimedia University (MMU). His expertise span telecommunication, intelligence system, and advanced data science with a focus on data communication, computer network, and machine learning. He holds certificate in security routing and switching and is recognized for his proficiency in Python, SQL, and MATLAB. So Dr. Hadrami has received numerous awards, including a gold medal in research, innovation, commercialization, and entrepreneurship showcase 2021 for his work on energy efficiency system for mosque building. He has also been honored with Best Paper Awards at prestigious conference, showcasing his contribution to artificial intelligence and energy efficiency in wireless network. So without further ado, I invite Dr. Hadrami to give his lecture. So
Thank you, Datuk.
let's start.
Assalamualaikum warahmatullahi wabarakatuh. My distinguished panel of speakers, Cikgu Hanafi, Mr. Febi, and respected audience. Okay, so today I have been invited to be one of the speakers for this forum. Okay, and the title of the forum is Artificial Intelligence Driven in Predicting Analysis. So I have some slides to be shared with you. Okay, I've seen that the previous two speakers have been talking about some real examples of AI-driven predictive analysis work, like Dr. Cikgu Hanafi has mentioned something on how we can use AI-driven predictive analysis in education sector, and Mr. Febi also has mentioned something on predictive analysis application. So for my part, I'm not going to give you any other specific case study. Okay, probably I will speak more on the general side of AI predictive analysis, AI-driven predictive analysis. Okay, we have, I think by now, some idea on what AI is, right? So we use AI because we know that the God-given intelligence that we have as a human being, and the intelligent features that we see in the various creatures that the God have given to us. From these intelligent beings that we see, we learn how we can mimic this intelligence and implement it in our daily life, especially our current modern daily life, which are so much connected to the machines and phones and computers. So when we talk about AI-driven predictive analysis, typically we will talk about one of the main cores of artificial intelligence, which are studied and designed and developed for helping the machine. When I say helping the machines, I mean helping the machines like computers, laptops, phones, and so on, to learn in the way the intelligent beings like human beings learn. So my focus of discussion is more on how we want to see the fundamentals of how AI-driven predictive analysis are implemented to let our machines to be intelligent, maybe not as intelligent as the human beings, but at least we want to train them. We want to train the machines and the computers so that they can perform some of the intelligent things, especially with regards to the predictive analysis. Okay, so I'm not going to speak about any specific case studies or problem domains about AI-driven predictive analysis, but I will be speaking more on the fundamental sides of AI-driven predictive analysis with regard to one of the main cores of AI, which is machine learning. So can we go to the next slide? Thank you. Okay. So predictive analysis, by now we understand, technically when we speak about predictive analysis, we mean that we want to forecast something happen in the future, okay? And that future can be a near future or a quite long future. So basically, if we have some sort of data in hand, so how do we use that data based on this data to predict something? So this is what had been mentioned by Cikgu Hanafi just now. We have some, as he said, historical data, right? Because the data has actually existed, and something that existed in the past, we can call it historical. So that's why we use the word historical. But never mind, we know that we do have some data. And this data, of course, if we manage to ensure that the data is trusted enough, the data is clean enough, the data is good enough, okay, so that we are not, we are ensuring that the predictive analysis that we're going to do based on the data will be as good as possible. I mean, if we are measuring it in terms of accuracy, then we want to make sure that it is accurate as possible. So we can then train the machine. We can train the model on the machine based on the data that we have, right? Okay, so I use the word machine, which refers to many things, including the computers. So my focus is more on to speak about the third one, as you see here. So we want to use this machine learning out of these three. Like, of course, we need the data, but I'm not going to speak too much on the data. It is a huge topic to be spoken about. And then I'm not going to speak too much on the statistical algorithms. I know out there we have some experts in statistical algorithms, probably those from the statistics background and so on. But probably I will speak more on the machine learning algorithms. So machine learning, as we understand, I believe we have some idea about machine learning. It is one of the main elements or the main types of AI. Why? Because our daily lives now are dealing so much with machines, right? So the AI that we learn, the artificial intelligence algorithms that we learn, typically we need to implement it on something, and that something must be something that is close to our daily lives. And as a human being, we are dealing with so much examples of machines like phones and so on, right? So we would see in some of the examples that I'm going to explain, which are more on the fundamental parts of how we can learn, how we can do the machine learning algorithms, implement them to perform the predictive analysis. So we do this, we use the machine learning so that we can identify, we can learn, we can see using the model, the predictive analysis model, we can identify and learn the patterns in the data that we have so that we can predict something based on that data for the future. It doesn't mean that it is not necessarily that when I say the future, it's not necessarily something that is long in the future. It can be a recent or a near future, something like just for classification, right? We have some data and we know that, for example, the data of I think when we talk about, for example, computer vision, the simplest examples that people used to talk, the people in AI likes to talk about computer vision is, for example, to tell apart between the cats and the dogs, for example. So we have some data on the cat and the dogs. So we use the model, the computer vision model, to predict whenever we are given with a picture, which can be either a dog or a cat. So we use that model to predict. So I'm using the word predict here, although it is not literally means prediction in time, but actually we are doing some prediction because we have some data in the past and we have a new data, which can be either a cat or a dog. So we predict whether that picture is a cat or a dog. So predictive is a huge topic. Okay, it's a huge topic. Predictive analysis. It can be used for classification. Okay, which I have been telling you about just now. Okay, for example, to classify between a cat and a dog, or it can be used for regression. Okay, regression is something like classification, but it is done for continuous values. Right. For example, you are predicting the temperatures, the stock prices. So those are considered as regression problems, which are also an example of one popular example of predictive analysis. Okay, and we can also do it on other examples of predictive analysis that we'll see later on. So we just want to see this thing. It is a bit technical. I'm not saying that I'm an expert in technical, but just to share some basic fundamentals on the technical side of machine learning. So as what we see in the slide now, machine learning algorithm is implemented based on some technically speaking, we call it data. Okay, data is the technical term that we use in machine learning algorithms. Without the data, it is very hard for us to implement it because it is a must for a machine learning to be implemented. We need to use this algorithm, the machine learning algorithm, so that it can learn something on the data that we have. Okay, but data is a technical term. In our daily life, we rarely use the word data. What we use is experience, right? So we know that our life, whatever that happened in the past, is called experience. So likewise, data is actually a part of our own experience or somebody else's experience. So an intelligent person is someone who learns from not only from his own experience, but any experience, even from others' experience in the past, so that he won't repeat the same mistakes that used to be implemented or that used to occur in the past. So data basically is whatever that we can collect and prepare based on the past. And physically speaking, or basically in the layman terms, we don't use the word data, but we use experience, right? So we want to train the machine learning so that it is experienced enough to make the decision, right? So the learning model is like a task for us. Okay, sometimes we are given with a simple task of identifying something like what I just mentioned to you just now, identifying between cats and dogs for the kids, right? For the kids. So machines are something like a small kid to us. They know nothing about dogs and cats. We need to train them. So just like a small kid, he knows nothing about probably cats and dogs until we teach him something, we train him. So we need this task of training and teaching the machine, just like we are training and teaching the kids. Because by right, machines know nothing about cats and dogs in this case, for example. So, and then what we want to measure is whether the machine can classify correctly whether the thing or the image that it is seeing is either a cat or a dog, for example. So measure is what we want the machine to understand, the machine to master. Okay, this is the basic idea of machine learning. So what is the difference between machine learning and the other types of algorithms or the other types of formula that we use to make decision? All right. Basically, this is another way of showing what I have spoken about just now. Before we talk about the simple rule-based decision, which I'm going to talk about in a few slides. Okay, but now what you are seeing in the slide now is basically another visualization of how can we understand or how can we relate between the historical data and experience. So I have told you about just now, the data is, or the historical data is basically our past experience. So technically in machine learning world, we call the experience as historical data. Okay, so we train our model, okay? We use our model so that it is trained on the machine, okay? So when the model is trained, we can say that basically the model is trained enough is good enough to make decision based on the data that it has, and the data must be something related to the data that we have trained to the model beforehand. Okay, so this is just another way of seeing it and comparing between the experience and the historical data. Okay, so we introduce the machine, we train the machine. Okay, so that the machine is regular enough, so the machine understands enough, familiar enough with whatever data that we have trained it with, and that it can make the right decision. Okay, this is what I wanted to say earlier on. The difference between machine learning and rule-based algorithm. Rule-based algorithm is basically a simple way of us making decisions, right? I mean, without any complicated formulas, we can make the right decision. For example, just to say whether something is big or small, do we need a machine learning to tell us? We don't. We don't need anything so complicated to tell us whether something is big or small, right? So we just need a simple rule-based algorithm, right? For example, if X is the input in this case, so if X is larger than a threshold value of maybe 10, so we call it big. If the X is, the input value is smaller than the threshold value of probably 10 again, then yeah, we say we call it small. So there are problems out there which are not complicated problems, which are not supposed to be solved by the machine learnings. We just need to solve it by using simple rule-based algorithms. So machine learning should be used to solve more complicated problems which cannot be solved by simple rule-based algorithms, like what I mentioned just now. To tell apart between dogs and machines, it's not that easy. There's no specific equation that can be used, okay, for you to tell apart, to tell the difference between a dog and a cat, right? So you need to train the machine by using some sort of machine learning algorithms, including the deep learning, so that it can understand, okay, this is a dog and this is a cat. For simple problems in our life, actually, we don't need machine learning. Okay, we just need simple rule-based algorithms, which are not necessarily a machine learning algorithm. But for more complicated problems, we can use machine learning, and we know that machine learning covers a lot of examples, including a lot of models, including the deep learning and so on. Okay, so this is an example, okay, a list of examples of problems that we can solve by using the machine learning. Okay, for example, we want to detect, to recognize the voice. Okay, to recognize the voice. It's not easy, right? It's not a straightforward problem. There is no one single line problem that you can use to tell apart between, okay, this is my voice, this is your voice, this is my teacher's voice, my friend's voice. No, it is not that straightforward. You need to use more complicated algorithms so that we can train the machine in a way that it can tell apart. Okay, it can classify the voice. So this is one good example of how we can use the machine learning. So for voice recognition, for example. Okay, and then for example, in the second example given there, in the part of speech tagging tasks, new words or meanings are generated at any time. This is also predictive, very good example of predictive analysis, right? You have an incomplete sentence and you want to predict what should come next after that incomplete sentence, right? So to predict what is the best word that should come next, you can have many examples of incomplete sentence. For example, the first sentence that you see in the slide here, okay, the solution to a problem is complex, comma, or the problem may, okay, you may create any examples including this sentence, and you just make it incomplete, and you try to predict the next word that should be inserted so that the sentence is complete. So this kind of example of problem is another complex problem that can be solved by using machine learning, for example, including deep learning and so on. And when I say machine learning here, we also include deep learning. And the next example given here, data distribution changes over time, requiring constant de-adaptation of programs, such as predicting the trend of commodity sales. This is also another complicated problem, right? Something that cannot be solved by using simple rule-based algorithms. Okay, to predict the amount of sales, very popular nowadays, okay, which is used in business intelligence and so on. So we have some sequential data, which has some sort of temporal element, time element. Okay, we have like data of sales in March. Okay, in March 2024, which is considered a past, which was last month, right? And then we have maybe another data of sales in February 2024, okay, which is considered a past data. So we have a sequential time series data from which we can use this data to be trained with some machine learning examples or machine learning models. Like one good example has been given or have been mentioned by Mr. Hanafi, Cikgu Hanafi just now, LSTM, and some of you have also talked about the what do you call it, GRU and so on. So those are examples of sequential modeling that can be done by using machine learning models. So those are examples of machine learning models that we can use for time series analysis, time series data. Okay, so obviously it is a complicated problem which cannot be solved by any simple rule-based algorithms, and hence we can actually use machine learning, including the deep learning. Okay, so I'm not sure, I think I do still have some time for the slides. Okay, this is again one way of looking at it. Okay, if we have simple problems, okay, simple problems with small data, then these simple problems are not supposed to be solved by the machine learning. We may have some complex problems, but we just need some small data to solve that problems. So in that case as well, you don't need any machine learning. We can just use manual rules. And if we have a simple rule, but the data is large, then you can simply use the rule-based algorithms, right? I mean, to make it more efficient to make decisions based on the large data that we have. And if we have really large data set with complex rule complexity, meaning the formula or the algorithm for you to make decision is very complicated, and in that case you need the machine learning algorithms. Okay, so we need to identify what are the problems, or what are the formulas that we need to use in order for us to make the decision. And then we need to also know the data, okay, what kind of data that is available for us to be trained with, okay, and then we can perform the learning algorithms. Okay, we can perform the learning algorithms and get the results from that trained learning algorithms. Okay, now we're going to just simplify everything, because actually we can still discuss more about the machine learning examples, but because of the limitation of the time, then probably we just jump to these examples, to these 5 key AI or ML based predictive analysis techniques. So some of these have been mentioned by our previous speakers, including like classification, okay, regression, time series analysis. Some examples like LSTM. Okay, we can use for example, like some deep learning models like NLP, for example, natural language processing. So some machine learning models or deep learning models like NLP, for example, we can use these models to solve more than just one predictive analysis problems. Okay, we can actually use, for example, NLP to do the classification, as well as the time series analysis. Okay, we can basically when we see these predictive analysis techniques, some examples that we see in machine learning that we have learned before. Okay, the models in the machine learning can be actually implemented in more than just one predictive analysis problems or techniques. So it depends on what kind of problems that we are dealing with and what kind of algorithms that we are using. Okay, clustering is for the unsupervised learning, meaning when the data that we know it's unlabeled. Okay, something that we don't know the label of the data. Is what we want is just to groups the data. Okay, and it is very hard for us to group the data because it is not labeled, but we know some of the data are having some similarities and differences between each other. So we use clustering to help us to cluster, okay, to group the data based on some similarities that will be learned by the machine learning. Okay, for other examples like classification, regression, these are supervised learning, meaning we already know the label or the target of the data. For example, if you have the data of students' academic performance, okay, like Dr. or Cikgu Hanafi has mentioned about the how we can implement the predictive analysis in the education sector. So we have some data on the students' performance. So the data like student performance most likely it can be done in, or it can be prepared in a label kind of data, meaning we can choose some of the features, especially, for example, the results of the students. Okay, the result of the students, whether the students fail or pass. Okay, that can be the label of the data. Right, so the label of data, whenever we can label the data, then we can do the classification. Okay, whenever we have the label of the data. Or simple examples like the dogs, right? We can have dogs and the cats again, okay? We can have so many images of the dogs and the cats, right? And that it is not hard for us to label or to annotate that, okay, this is the picture of the dog. And then you take another picture of a dog in a different angle. Okay, this is also another dog. And then you have another picture of a dog, but from a different angle. And then you also label it with the same label, which is a dog. Right. So this kind of data is basically used for, we call it supervised learning, because you as a human being, you supervise the machine. Okay, this data, you tell the machine is for the dog. This is another data is for the dog. This is another data, but this one is for the cat. This is another picture. This is for the cat. This is another picture from a different angle. This is for the cat. So you supervise the learning process of the machine. Okay, supervised learning we call it. But sometimes maybe the data is too large, or we have no idea how to classify or label the data. But we want to see some relationship, some clusters of the data, some groups of the data. So in that case, you don't supervise the learning. You let the machine to learn itself by itself and tell you, okay, how many groups you have. Okay, so that one is called as unsupervised learning. There are so many examples that you can think of. Okay, this is just one simple example that I can say. Time series analysis, this is very popular as well. This can be also part of classification as well, and can also be part of regression as well. So they are not like totally different between each other. For example, you can use time series analysis with regression, like weather forecast. Weather forecast can be a regression and a time series analysis, because weather forecast is something dealing with continuous values, right? Because the weather is continuous, can be continuous, especially if you are measuring. It can be also classification, but if you are measuring, for example, the amount of rain that is going to be poured down tomorrow, right? Or basically, if you are measuring about the stock price, a very simple example is stock prices. You want to predict the stock prices. So the stock prices are very continuous in nature, right? It's not discrete. Okay, it can be 100 ringgit, 101 cent, or 102 ringgit or whatsoever. So the values can be continuous in nature. So this is regression. By nature, this is what we call as regression. We don't classify it in discrete values like A, B, C. So, but then regression in that case, stock prices prediction is also an example of time series analysis, because you need to train the deep learning algorithm or the machine learning algorithm with time series data before you can perform the regression operation. Okay. Anomaly detection is for detecting. This is something which is unusual in the data, right? Can also be done by using the machine learning. So this is what I've been talking about just now. Supervised learning, unsupervised learning, semi-supervised learning. You might have a mixture of the two. Okay, you have some of the data which are labeled, and the majority part of the data which is unlabeled. So when you're dealing with this kind of data, then you can call this as semi-supervised learning. Okay, reinforcement learning. This is another very popular topic in AI nowadays, which has been used in many fields. So reinforcement learning, as you can literally understand, okay, by going through the name, okay, it keeps in this reinforcement learning, basically you reward, okay, the algorithm keeps rewarding. If certain conditions are satisfied, it keeps rewarding the process, the process. But if the condition is not satisfied, so the other, basically the negative reward is given, basically something like that. So this is another popular way of a popular field in machine learning and AI for doing the predictive analysis as well. Okay, this is supervised learning. Okay, you see here, I think in supervised learning, basically you already have the goal, the label. So by using the labels that you have, then you can start teaching or training the machine. Okay. Regression is for the case of data which is continuous in nature, like the temperature in this case. So it is continuous in nature, then we use regression. Okay, classification is for discrete kind of data, okay, to classify between from the A and B. So A and B are obviously discrete, right? Okay, and then unsupervised learning is for you to, when you have no labels in the data, then you want to just see the relationship between the data that you have. So in a way, you want to see the clusters or the groups of the data. So you do unsupervised learning. Okay, clustering. Clustering is an example of unsupervised learning. Semi-supervised, when you have two kind of data, okay, meaning you have the labels. Okay, the label is supposed to be in the table, but somehow it is missing, but it's okay. Okay, some of the data is labeled, some of the data is not labeled, so you can use semi-supervised learning. This one also, this is not the real, somehow, you know, this the actual figure somehow is missing now, but it's okay. The main idea is that whenever some of the conditions are satisfied, you can reward. You can reward via the feedback loop that you have. You can reward the system, the model, and otherwise. Okay. All right. That's all about the basically some examples of predictive analysis. I mean, the major examples of predictive analysis that you can do using AI. Okay, I think the main slides that I have been presenting just now is basically taken from Huawei and some other internet sources. Thank you very much. That's all.
Okay, thank you to our third speaker, Dr. Hadrami, for your enlightening presentation on AI-driven predictive analysis. Your expertise has deepens our understanding of these complex topics and spark provoking discussion. So we appreciate your valuable contribution to the session. So next, I will read some question from the audience. I will choose. I think I have some question from the previous. Okay, from I read this question is from the previous speaker, but I reserve to Dr. Hadrami lah. It's very simple. From Noor Sheila Cik Nabi, what is the cause of failure in predictive analysis? Cause of failure in predictive analysis.
Thank you, Dazu. The questioner is an expert by herself, so I'll try to answer. Okay. So there are many causes of failures in predictive analysis. One simple example is when you have, for example, insufficient data. Okay, when you have insufficient data, then you train your model, your predictive analysis, your whatever model that you're using, for example, in this case, if you're using LSTM, you train your LSTM model with that insufficient data. So what happened? To simply explain about this concept, maybe you can try to imagine you want to train your kid, you want to train your kids, okay, to learn something, but the things that you teach him or her is insufficient enough. Meaning, yeah, okay, you just tell him once, okay, this is nasi dagang, okay. You just imagine one fine day in Terengganu, you went to Terengganu, you go to Terengganu and you find one nasi dagang in Terengganu. Then you tell your son, okay, my son, this is nasi dagang. And then one day your son come to Kelantan and then he found another nasi dagang, but from Kelantan, which is slightly different, but it is also called nasi dagang. And then he cannot tell you this is also nasi dagang because we have just taught him with insufficient data, saying that nasi dagang is only from Terengganu. He didn't mention it, but by giving one of the example or one of the data that you have given to your son about the nasi dagang, which is insufficient, making him confused, okay, to tell you that basically we also have another kind of nasi dagang which is from Kelantan. So this is one common reasons why you get errors or insufficient or basically lacking of accuracy when you do the predictive analysis. And you can have other reasons or other causes of failures like overfitting. For example, overfitting is it can happen when you have your model too complicated, okay, too complex model, which is implemented on just a simple size or simple or small size of data. So in that case, your model, instead of you train the model to understand the data, what happens is that because the model is too complex, it is instead of learning about the data, it is memorizing the data. So in that case, when the model is overfit, when you test the model with another, when you do the testing, and basically you want to evaluate the system, the model, you test another data, the data or the model cannot tell you, cannot give you the right answer, because instead of understanding the data, it is memorizing the data because it's too complicated. The model is too complex, so it causes overfitting problem. And you can have maybe other reasons, like, for example, you might make incorrect assumption. For example, if you are, we come back to the example that I have given in the talk just now, right? You want to teach the machine about dogs and cats, but somehow the person or the one who is in charge of annotating or labeling the data mislabel the data. Okay, all the images of dogs have been labeled as cats, and all the images of cats have been labeled as dogs. So this is misinterpretation of the data. So if you use this misinterpreted data and you train your model using this misinterpreted data, or basically incorrectly labeled data, so what happens is that the result will not be correct. So there are many other reasons, and so I've just given you some reasons. You can start to explore on your own to see other examples or reasons that make your predictive analysis incorrect. Okay, I think that's all for my answer so far. Yeah.
I think that is a good answer, Doctor. Okay, this from Rose Prudence Ade. So can we also have the slide after the presentation? This one, you need to fill out the form. So we will discuss on how we going to distribute the slide. Okay. The second question for Doctor, can you share some tips for beginner who wants to use machine learning algorithm or predictive analysis from Ika Abdullah?
Okay, thank you. I can see that Ika Abdullah is a very active student. If we have some sort of awards to be given, then she could be one of the potential candidate. Okay. How can we to start learning for the beginners to use machine learning algorithm or predictive analysis? Yeah, I think this is my opinion. You can agree with me or not. So this is just based on my simple opinion. All right. Based on my experience, based on my little experience about AI and so on. For my case, for example, I like something visual in nature. So it depends on. I think basically it depends much on your interest. So in my case, I like something visual in nature. So I like to deal with images. So if you like to do something on images, I would suggest that you start learning machine learning algorithms or predictive analysis, which uses the computer vision. Basically, in AI, we have so many subfields under AI, right? So one of the most popular fields under AI nowadays is computer vision. So the examples that have been talking about just now, you see, I have been talking about the dogs and cats, right? So dogs and cats, in order for us to train the machine to understand whether the image is the image of a dog or is it the image of the cat, that is an example of computer vision. Okay, so computer vision is one subfield of AI. Okay, we want to teach the machine to understand what it sees. If you want to teach the machine to understand what it reads, then you use NLP, natural language processing. Okay, for synthesis analysis, sentiment analysis, and so on, right? So if you want to teach the machine to understand what it analyzes, okay, when the data is in the forms of numbers and so on, then you can use RNN and so on, like LSTM, whatever. But if you want to teach the machine to understand something that it sees, actually, the formula is not that easy. It's very complicated. But for you to enjoy learning it, to me, this is very much enjoyable because it's very easy. Nowadays, there are so many simple, free platforms on the web for you to learn. Okay, I would suggest, okay, if you like something like images and so on, you go to Teachable Machines. Teachable Machine. You can search Teachable Machines, and you can just follow the instructions there, how you can train, how you can create a simple model, okay, teachable machine, to train the model to understand about computer vision. For example, you want to train the model to understand this is thumbs up, this is thumbs down. So you can take your own pictures your own thumbs pictures, and then you can feed the pictures inside the system, teachable machines, okay, which is available online for free. And then you can start train, and then you can see the results there and then very quickly. And then you can also download the code in Python, if you like Python. Okay, and you can also embed in your own web. Okay, and you can also, if you want to make it further, you can also embed it in your own apps as well. Okay, so within a few hours, if you really focus on it, you can create your own apps to identify images of dogs and cats, for example, or to identify, okay, this is thumbs up, this is thumbs down. Very simple and yet interesting examples of how you can implement. In this case, this is deep learning, but then it's very simple examples of deep learning. And you can see the process of training. Okay, you have your input data. Okay, you feed the data to train the machine, and then you can then train the machine, and then when the machine is trained and ready to be tested, the next level is you test the machine with another picture, whether to understand, to test or to check whether the machine has already understood what you have teaching. Okay, you go to teachable machine. You can go there and play around, and hopefully you will appreciate further. Okay, that's all from me. Thank you.
Okay, next question, Doctor, from Ahmad Fahmi Ahmad. What ethical concern might arise from predictive analysis using social media data?
Okay. Thank you, Fahmi, for asking the question. Okay. Ethical concerns in AI have been a very popular topic. In Europe, it is a very serious topic, especially when you are dealing with computer vision things. For example, one of my projects currently, I'm working on motion and emotion detection. Okay, motion and emotion detection. Emotion detection is very sensitive. It's a very sensitive topic, especially in the Europe. Because you need to, in order for you to detect the emotion of somebody, you need to obviously capture his face, right? So when you are capturing somebody's face, obviously it is something quite privacy, especially to those in the Europe. For them, this is very, too much for them, some of them. So they are more concerned with these ethical issues, okay, in the computer vision fields, for example. So my answer to this, first, it depends on what kind of data that you are dealing with. Okay, so in this case, for example, if you are dealing with social media data, to me, it is better for us to try to get the data which is not so much personal. Okay, there are many. This is the best practice that you want. If you want to start doing the predictive data, predictive analysis job, or if you want to do any predictive analysis projects, the best. For me, it is good for us to start with the public and publicly available data, which is basically a data that is supposed to be available and can be used by everyone. If you want to use the social media data, then it is very common sense for you to know whether the data is considered as too personal or not. If the data is too personal, then I would suggest that you don't take it. Otherwise, you might have some problems in the future. Okay, so this is something that you have to think of. So if the data that you are getting from the social media is just general data, which is not too personal in nature, okay, you're not taking for example, the IC numbers of the people. Even you're not taking, we don't need the names of the people. Sometimes we don't need the names of the people, right? Do we need the name of the people for us to do the training? What we need is to just, for example, what I'm doing now, some of our researchers are doing in our university at the moment. We are doing prediction on the students' performance. Okay, so of course, you can get some data about the students' performance, and inside the data, you might have the names of the students. But we don't need the names of the students. What we need is just the result of the students and some other features of the students' performance, including, for example, the test results, the attendance of the students. Okay, so there are so many other insensitive or impersonal data which are not personal, that you can use for you to perform the predictive analysis. So just try at your best to avoid any data which is too personal. Just get the data that you really need. Okay, I believe we don't need those too personal data, including the names and whatever, the IC numbers. What we need is just typically what we are dealing so far is just, for example, if you're talking about the academic performance prediction, then we are just interested with the marks. Okay, just remove all the names. We have publicly available, for example, data set for the student performance prediction, like the outlet data set that have been used by one of my PhD students. It is okay, no problem with the sensitive or not data and so on, because what we have in that data set is just the result of the students, and based on the subjects, we don't have any sensitive data like the names of the students and so on. So this is my advice. So discuss with your team, and if we need any kind of NDA and so on, you have to really make sure that you get it signed and so on. Otherwise, I would suggest go for the publicly available insensitive data, by which you can also get the same result that you want. This is my simple advice. Otherwise, just try to focus on those insensitive data. All right.
Okay. All right. So we have a last question before we end our webinar today. From Rose Prudence Ade. Doctor, what is the direct reinforcement learning process?
Okay, reinforcement. All right. Okay. Thank you. All right. To be honest, I don't have any practical examples of reinforcement learning projects in my research so far, but I do have some of my co-researchers who are actively engaged in in reinforcement learning. Okay, so I'm not sure what do you mean by direct. Okay, direct reinforcement learning. I mean, what is the direct reinforcement learning process? Okay, but what can I say is that the reinforcement learning is it is iterative in nature. So you have some sort of rules and some sort of conditions that you set in the process. Okay, when you start doing the learning process, and you identify that when you are running the process, you identify that the process is positively learning something based on the condition that you have set from the problem or from the data that you are training with. Okay, then you will basically add the reward. Okay, this is what the idea is. Okay, so meaning the learning process, the reinforcement learning process is basically reinforcing the learning. So meaning it is learning the right thing now, the positive thing. So it will be rewarded. Otherwise, if it is not it is not fulfilling the condition, then you won't get rewarded. So basically, the process is iterative. Okay, it's like you have a feedback loop, keeps checking the condition. If it meets the condition, then it will be rewarded. Otherwise, it will not be rewarded. And based on that, after some stopping condition, then you can basically finalize the result of your reinforcement learning. So you have like an agent to learn, to make the sequential decisions. So it is sequential in nature because it depends on the iteration, right? Okay, the first iteration depends on the past iteration. If the past iteration is giving you some sort of reinforcement or reward, then basically the amount of the total reward will be bigger, and otherwise it will be reduced. So, okay, so that's the basic idea of reinforcement learning. All right. Thank you very much.
Okay, that's come to end for today. So I would like to say thank you to our speaker, Cikgu Nafi, Febi, and Dr. Hadrami for very good session and sharing for today. So before we end, I just want to remind that everyone for fill up the form for the attendance form, and then so for your information, we have another webinar on next month, end of month. So I think keep keep visiting UMK Facebook. And before we end for today's session, so I apologize for the technical issue that interrupted the presentation on Cikgu Nafi. And ladies and gentlemen, as we conclude our session on AI-driven predictive analysis led by our esteemed PhD student and lecturer, on behalf of UMK, University Kelantan, I want to express my gratitude for your active participation. A very good question that posted by our audiences. And let's carry forward the insight gained today and apply them responsibly in our endeavors. So thank you for joining us, and goodbye. So we end our session today with Surah Al-As. So wal-as innal insana fi khusr alladzina amanu wa amilus solihati wa tawassaw bil haqqi wa tawassaw bis sabr. So thank you. So inshallah we can meet in physical. So Febi are going to come here. Okay, so yeah. So thank you everyone. Bye. Wassalamualaikum warahmatullahi wabarakatuh.
Warahmatullahi wabarakatuh.